Hi, welcome to Chemistry, Unit 3, 3.1 on chemical bonding. Today is video 4 on polyatomics and transition elements. If you're in class, you have a handout that goes with the next few slides where you need to fill in their names and formulas for the most common polyatomics. If you are at home, you are going to want to write these down on your formula sheet so that you always have them with you. Polyatomics in your notes are compounds that are preformed with unique names and charges or oxidations. They can and will ionically bond with other elements and compounds. So the following is a list of polyatomics with an oxidation of 1 negative. They're similar to group 17 on the periodic table. They are acetate, bicarbonate, chlorate, cyanide, hydroxide, nitrate, and nitrite. The formula for acetate is C2H3O2. Bicarbonate is HCO3. Chlorate is ClO3. Cyanide is Cn. Hydroxide is OH. Nitrate is NO3. And nitrite is NO2. These are a list of polyatomics with an oxidation of 2 negative, similar to group 16 on the periodic table. They are carbonate, chromate, peroxide, sulfate, sulfite, and silicate. The formula for carbonate is CO3. Chromate is CrO4. Peroxide is O2. Sulfate is SO4, sulfite is SO3, and silicate is SiO3. These are polyatomics with different oxidations. There's not a consistent list of them. So, an oxidation of 3 negative is phosphate. 1 positive is ammonium. 1 positive is also hydronium. Whereas 0, an oxidation of 0, is ammonia and methane. The formula for phosphate is PO4. Ammonium is NH4. Hydronium is H3O. Ammonia is NH3. And methane is CH4. So, the following are polyatomic ionic examples. If we wanted to combine aluminum and sulfate, aluminum has an oxidation of 3 positive and sulfate has an oxidation of 2 negative. And because it is an ionic bond, the oxidations would crisscross. But notice that SO4 is a compound all its own. So we put it in parentheses to keep it together because the 4 there in that formula goes with oxygen only. So this would be read Al2SO4 3. Potassium and nitrate would simply be KNO3. Ammonium and chlorine would be NH4Cl. And ammonium and nitrate, because 2 polyatomics can bond together, would be NH4NO3. Finally, we're talking about transition elements. The transition elements get their names because they have variable oxidation numbers. Their oxidation numbers, however, are always positive, and you are told or given a transition element's oxidation number with a Roman numeral. So they will bond ionically with other elements and compounds. For example, copper 1 and oxygen means that copper has an oxidation of 1 positive. Oxygen from the periodic table has an oxidation of 2 negative. When they crisscross, they make Cu2O. Iron 3 and chlorine Iron would have a 3 positive, chlorine would have a 1 negative, and again they would crisscross to make FeCl3.